Okay, so today we want to just go over a little bit of some of your homework. Is it a solution? So let's go over compound ORs. So compound ORs, remember, to be a solution, it has to work for it has to make at least one of the sentences true. So at least just one of the sentences true. For a compound and, it has to make both of the sentences true to be a solution. So in the first three problems, state which of the following numbers in the set is a solution to the compound sentence. So let's see if 0 is a solution to the compound OR. So it has to make at least one of them true. So is 0 greater than 10? False. Is 0 less than 2? True. So 0 is smaller than true. It didn't make the first one true, but it made the second one true. So therefore 0 is a solution. So 0 is a solution. Let's check number 5. So we have to do a lot of erasing, right? So on your homework, you should probably, you should actually show us what you're doing. You shouldn't erase it. We should see the check to see. So is 5 greater than 10? False. Is 5 smaller or less than 2? False. 5 did not work for either of them, so 5 is not a solution. Remember, it says state which of the following numbers is a solution, right? We're looking for the ones that are solutions, so this is not a solution. -6. So is -6 a solution? Let's test it out. Is -6 greater than 10? False. Negative numbers are never bigger than positive. Is -6 less than 2? Yes, negative numbers are always smaller than positive numbers. That's true. It did not work for the first one, but it did make the second one true. Therefore, -6 is a solution. Now let's test 12. Is 12 a solution? Is 12 greater than 10? True. Is 12 less than 2? False. It did not work for the second one, but it did make the first one true. So since 12 made one of the sentences true, it is a solution. Remember, it only has to make one of them true to be a solution. So 0 and -6 and 12 are all solutions to that compound OR sentence. This time we have a compound and. Remember, to be a solution to a compound and, it must be true for both. So let's test 6. Is 6 smaller than or equal to 5? That is false. Is 6 greater than or equal to -2? That is true. So it has to make both of them true, and it did not make both of them true, so 6 is not a solution, right? 6 is not a solution. So technically, once I found out that this one was false, did I even have to really bother testing this one? Because if it has to make both of them true, right? Both of them have to be true. As soon as I find out that this one's false, I probably can stop and say it's not a solution, right? Doesn't that make common sense? Is 0 a solution to that compound sentence? Is 0 less than or equal to 5? True. Is 0 greater than or equal to -2? True, because 0 is always bigger than any negative numbers, so it made both of them true, so therefore 0 is a solution. So you could pause the video and try the next two and see how you do, right? Pause it and see how you do. Let's try -2. Is -2 less than or equal to 5? That is true. Negative numbers are always smaller than positive numbers. Is -2 greater than -2? No, but it says or equal to. So it is equal to -2, so that's true. So because it made both true, -2 is a solution to the compound sentence. -1. Is -1 true to the compound sentence? -1 is less than or equal to 5. Negative numbers are always smaller than positive numbers. That's true. Is -1 greater than or equal to -2? That is true, People always get that one wrong. So remember, if you have 0, you've got -1, you've got -2. Any number that's closer to 0 is going to be bigger, because remember, as you go further, the numbers get smaller, and as you go further to the right, the numbers get bigger. So any number that's closer to 0 is going to be bigger than -2 when you're looking at the two negative sides. So since it made both of them true, that means -1 is also a solution. So 0, -2, and -1 made both sentences true, so they are solutions to the compound sentence. In example 3, we have what's called a between statement. So remember, this means that if you read it Hebrew style, if we rewrite that, that means n is greater than or equal to -4 and n is less than 6. So remember, that's just a way to write. And you can also read this. So you can also read this as all the numbers, let's just say numbers between -4 and 6, including -4, because -4 has an equal to symbol. So including -4. So that's another way to read this. So that's how you read that, right? So let's test 0. So if we plug in 0, is 0, so is 0 less than 6? Yes. And then is 0 greater than -4? Yes. So it made both of them true, so therefore 0 is a solution. So plugging it into the between statement may be kind of hard for you, because one of them you're reading backwards and then other one's reading forward. Or you can just think of, is 0 between -4 and 6, right? Is the number 0 between, is it between -4 and 6? And it is, so it is a solution, right? Is -7 a solution? So we can plug in -7 here. Is -7 greater than or equal to -4? That's false. So I don't even have to try it in the other one. It's true for this one, but not for this one. So -7 is not a solution. In other words, is -7 between? Is -7 between -4 and 6? Is it really between? No. Let's look at the number 6. Is the number 6 between -4 and 6? No. So if we break it down and we throw it in here, is 6 greater than or equal to -4? Yeah, positive numbers are always bigger than negative numbers. That's true. But is 6 less than 6? 6 is not smaller than 6. It's equal to, but there's no equal to symbol in there. So that's false. So this part's false, right? 6 is not less than 6. That's false. This side over here is true. So it did not work for both, so that's not a solution. It's an and, it has to work for both. And 6 is not between -4 and 6, including -4. Is -4 between, so if we plug in -4 here, right, and we go look at this side, is -4 less than or equal to -4? Isn't that true? Because it's equal to. And then is -4 less than 6? That's also true. So it made both of them true, therefore -4 is a solution. Again, you can break it apart if you wanted to. If you wanted to break it into two separate ones and then test it, is -4 greater than or equal to -4? Yes, because it's equal to, so that's true. Is -4 less than 6? Yes, that's true, because negative numbers are always smaller than positive numbers. So again, -4 is a solution because it made both sentences true. What about 3? On this one, they want us to write an inequality that would match each graph. Remember, what we're shading are solutions. So wouldn't you agree that the numbers that we see that are shaded are numbers that are bigger than 1, right? Don't you see that? All the numbers that are shaded here are the numbers that are bigger than 1. And so how do we say that? We can use n or x or y. We should always put the variable first, and we see all the numbers that are greater than 1. So that's the inequality that matches that picture. Here we have solutions on each of the ends. We have solutions to the left of 4, and we have solutions that are to the right of 7. So because they're separated with a gap, we have to write a compound OR. So we have to say all the numbers that are less than or equal to 4, that would be this side, right? Or, we have to use the word or, not an and, all the numbers that are to the right of 7 would be all the numbers that are greater than 7. So notice that because this was shaded, I had it equal to, and notice that this was open, so I just had the less than symbol, and you have to have the word or. We do not want you to write it backwards, so don't write n is greater than 1. Don't write this backwards. Write it with the variable first. So this is the correct way. We don't want you writing it backwards, so this is the way we want you to write it. So write your variables first. Right? Write your variables first. So that should be your answer for number 5. Number 6, the solutions, what do you notice? Aren't the solutions between 3 and 6? So we would say the solutions are between 3 and 6. So the solutions are to the left of 6, so that would be less than or equal to, because it's solid. And they're also to the right of positive 3, so that would be greater than or equal to 3. So basically, when you're writing a between statement, these are always going to be less than symbols, right? They're always going to be less than symbols. So if you wanted to, you could break it down and you could say all the numbers that are bigger, right, that are to the right, that are greater than or equal to 3, and then you have to write the word and all the numbers that are to the left or less than 6. So this is also okay, but we really would prefer the between type statement. So we really prefer this between type statement. Technically, they're both true. Okay, so I hope that helps you with a little bit of tonight's homework.